Good afternoon. I'm Beth Papanek, and I'm with the company SonOPore for the optimization of genetic engineering. So just to give you a little bit about my background, I did my bachelor's and master's at the University of Illinois, and now I'm in a PhD program at UT. It's an interdisciplinary program in energy science and engineering in the Bredesen Center, and it's a joint UT-ORNL program. And because it's interdisciplinary, while we are doing science, it encourages interests in other areas as well, such as entrepreneurship or policy. So that's how I got started. So this diagram shows the entire biofuel process. So there's a lot involved in making biofuels, but my technology is looking specifically at the microorganisms. So all biofuels are produced by feeding some form of sugar to some form of microorganism to produce the chemical you're looking for. So to optimize this process, you also have to optimize these microorganisms. So the problem is that right now, that's an extremely difficult process to do. It involves preparing the cells and then using an high electricity, 15 to 1800 volts, to shock the cells to allow them to take up DNA. So all of that cell prep is required, and then each time you shock them, it requires a mini electrode that costs $3 a reaction. For labs that are doing thousands of these a year, that really adds up quickly. So the solution that I'm proposing is using ultrasound waves instead of the electricity to shock the cells, or SonOPoration. So this would require no cell prep, and it removes the cost of those individual electrodes. So basically, you'd be going from what's on the left, a machine with the little electrodes and an extremely long and tedious protocol for cell prep, to a simple machine as the one shown on the right. The market potential for this is, well, the entire transfection market is about $400 million, and that's any form of cell disruption for DNA uptake. Of that, electroporation is about $100 million, or a quarter of that. Since the SonOPoration using the ultrasound waves would be a direct replacement for the electricity, this is the market we're targeting. And while I talk about biofuels, this also covers the market bases in pharmaceuticals, health foods, bioplastics. But the reason I talk about the biofuel industry specifically is that's where I have connections and the most knowledge. Most advanced biofuels are made with these forms of cells, and right now that would give a $5 million initial traction. So moving forward, it would require a minimal amount of strain verification just to prove that everything is working properly, some design and outsourcing of the manufacturing of the actual machines, and then finally, again, gaining that initial traction and selling them to the biofuel companies. Eventually, I think that this would make an excellent acquisition target. These are the companies that currently produce the machines for the electroporation, and I think that by acquiring this technology, it would make an excellent addition to their product portfolios. So if you have any questions, I would be happy to answer them at my table.